Welcome back to Wages and Employment at Wilfrid Laurier University. Today we are introducing our basic labor supply model. In this video, we're going to keep things simple and start by understanding preferences. In subsequent videos, we are going to build our constraints and learn to characterize optimal choices. For reference, you should pair this video with readings in Chapter 2 of your textbook and take a look at the online appendix. Now, I like to start by reminding everyone that the models we use here are really quite intuitive and represent a simple story. Basically, all of us need to decide how much we will work in the paid labor market. And when we make those decisions, we think about the world around us, what we like and what we don't like. Generally, the goal here is to be as happy as possible. It's really that simple. But unfortunately, we can't always get what we want. Really, that's all there is to it. So we take that story and characterize it with a set of equations. The model we're going to work through is your standard model of constrained utility maximization, similar to the ones you've seen in microeconomics to describe how people choose bundles of goods. But here, people are going to decide how much to work in the paid labor market to make themselves as well off as possible. We'll start by introducing some key concepts. We'll keep it simple and model a world with only two goods to consider. The first is leisure, which is really all the time people spend doing things that aren't paid work. We think of people liking leisure, things like sitting on a beach or going out with friends, but this simple concept really neglects that part of non-market activity we might not enjoy so much, like changing baby diapers or mopping floors. But it's the terms we've used for so long, and the textbooks aren't going to change it anytime soon. So the second good here is consumption. This is an aggregation of all the goods and services we like to buy. It's like an abstraction in some ways, but it's easier to model it as a single bundle of goods, as though your choice of exactly which goods and services you buy can be dealt with separately. Now in the background, we will have a utility function in mind, which is going to be a formula used to characterize how we combine consumption and leisure to give us utility. But we start with something simpler. We like to represent utility with a set of indifference curves. Each curve is going to show us combinations of consumption and leisure between which we are indifferent. So we're just as happy at each point on any single curve. This is what the curve looks like. We like working with two goods because the indifference curves are easy to map out in two-dimensional space, so on a nice flat piece of paper. So in this diagram, which is actually figure 2.5 in your textbook, we show a single indifference curve labeled U0. Each point on this curve represents a bundle that the individual is just as happy with. So this person is just as happy with bundle A, with very little leisure time, but lots of goods and services, as they are with bundle B, where they get to enjoy lots of leisure time, but not as much stuff. We say our indifference curves exhibit diminishing marginal rate of substitution, or MRS. In the figure, the slope of the indifference curve gets flatter as you move to the right. But really, this is about what trade-offs we're willing to make and how that depends on your starting point. When we have lots of consumption goods at point A, we're willing to give up a fair amount to gain some leisure time, which we had very little of, and move to point C. But when we're at point C with less consumption goods, we need a lot more leisure time to be willing to give up a smaller amount of consumption and still consider ourselves just as well off as we were before. Now at this point, it's worth taking a bit more time to think about what the slope of our indifference curve really represents. Intuitively, it's telling us about our willingness to exchange leisure for consumption without being made any worse off. In other words, as we move along the indifference curve, the change in utility is zero. Now, what we are going to do, or what we are doing when we move along the indifference curve, well, we have some gain in leisure with a change in utility associated with that. That is the marginal utility of leisure, which we denote here as MUL. We also have some loss of consumption, a change in consumption, and a change in utility associated with that. That is the marginal utility of consumption, or MUC. As we move along that indifference curve, all those changes need to balance out so that overall there is no change in utility. Now we can use that identity to see that the marginal rate of substitution, or the slope of that indifference curve, is really the ratio of marginal utilities. And I'm going to point that out now because we're going to use that later on when we start solving some problems. Okay, so it's important to remember that every point in this two-dimensional space between consumption and leisure is associated with some level of utility. And there's an entire map of indifference curves to describe which combinations people are indifferent between. Here we're showing just 3 of those curves. The main thing here is that individuals have more consumption, the main thing here is that when individuals have more consumption goods or leisure time, they are assumed to be better off. So in this diagram, all points on the curve U1 are representing higher utility than points on the curve U0. An important thing to remember here is that for a rational person in our models, these curves will never cross. So for example, suppose we bring in this extra curve colored blue here. This curve the curves cross, and we'd have a situation where this person with a gain in consumption goods appears to be no better off. So following along that curve U2, they're indifferent between these 2 points colored black. And since one of those points is also on the blue curve, they must be indifferent between those as well. So it looks like the person has more consumption, but is no better off. And that just doesn't make any sense here. So I'm just going to point that out so that we can all avoid that mistake in the future. Now, I'll also point out that these curves should never be upward sloping. So for example, consider this red indifference curve that I've drawn in here. We have a situation at the end of this curve on the right-hand side of it, where people are getting both more consumption and leisure, but appear no better off. Since we expect people like more leisure time and more consumption, this wouldn't make any sense. So we don't want to see this in our graph either. Now, just one more thing about preferences. We aren't able to compare levels of utility across individuals, but we can compare how they are willing to trade off consumption for leisure time. Here we have indifference curves for 2 different individuals. And notice that the one marked Bob is flatter. Anna's is steeper. So with a starting point at A, Anna requires more consumption to give up some of her leisure time than Bob does. She has a higher valuation of leisure. This is reflected in the fact that the curve for Anna is steeper, and we would say that the marginal rate of substitution between consumption and leisure is higher for Anna. Now, when we return to this more formally, we'll be looking at something like this. The story here is that people want to be as well off as possible. They want to maximize their utility, and they will choose the bundle of consumption and leisure that will do that. We'll use a function to characterize how the choice of consumption and leisure translates into utility. I've provided a really simple example here with C squared L. But before we do that, we need to think about how those choices are constrained, which is in our next video, where we look at how to construct our most basic budget constraint. See you then.